Hello and welcome to this video explaining the ReadSpeaker demo.
This is an example of ReadSpeaker being used in Unreal Engine 5. First of all, I'm going to give you an introduction to the project, so I'm going to press play and show you how it works.
Welcome to the ReadSpeaker Unreal plugin demo project. Main menu play, button, 1 of 3, A to select.
So you'll hear there that the narrator is reading out an introduction sentence on this menu. It's reading out the button, its position, and how to interact with it. And if I move down,
Options, button, 2 of 3, A to select.
You can see that it's updating. So I'm going to enter into the options menu now.
Options menu narrator volume, slider, 40%, 1 of 5, D-pad left or right to adjust, A to go back.
So you can see that there's some options here that we have for the narrator. So this is using the volume, speed, and pitch variables, and also changing voice packs. So if I go down,
Narrator speed, narrator pitch, narrator voice, option, feminine 1, 4 of 5, D-pad left or right to adjust, A to go back.
Masculine 1.
Feminine 2.
Masculine 2.
so you can hear that the voice pack is updating as we're making these changes. I'm going to go back to feminine 1,
Feminine 1.
and we also have
Audio description voice, option, masculine 2, 5 of 5, D-pad left or right to adjust, A to go back.
So we have a separate voice here for the audio description. I'm going to keep these as masculine and feminine just so that we can tell the difference when we go into the project. So I'm going to go back now.
Options, button, play, button, 1 of 3, A to select.
You can see that we've also got it stopping the narration and updating the narration when the focus changes. So I'm going to hit the project now. So you can see I've loaded into this level. We have two big white plinths in front of us. One of them has audio description example written on them, and the other one has HUD trigger example. So I'm going to run over to the audio description example first.
A big, empty text room. Two panels are in the middle of the room. One reads audio description example and the other reads HUD trigger example.
So you'll see there that the character has entered some kind of collision box, and there's some audio description playing that explains the room. I'm now going to move over to the HUD trigger example.
Use WASD to move.
So you'll see there that there's a HUD piece that's popped up that says use WASD to move, and then the narrator is reading that out as well. If I hit pause on here,
Pause menu resume, button, 1 of 3, A to select.
we also have a pause menu, and we have the same options that we had available to us before in the options and exit to main menu. And that's an overview of what the project is at the moment.
So how are we actually going to make the TTS say something?
So I have this speaker item here, which you'll have in your blueprint as well, and it has a component which is the text-to-speech speaker. I have added this to my main menu, and it's got a couple different things on it. The first thing is the event begin play. It initializes, it adds an audio component, it sets the audio component as the speaker, and then we also have set UI sound. This node is very important. It makes sure that the sound is going to play even when the game is paused, so that it will work for our pause menus. This event here, called speak, is a custom event that I've made. It has an input of a string, and this is saying this is the text that it needs to say. The first thing it does is it interrupts the speaking of any speech that's going on at the moment. So this means that if you change focus on buttons, for example, it will stop describing the previous button and start describing the button that you've just changed your focus to. And then we have this node which is say async. So this is just having the target of the speaker and then the string text to go in. And text type is normal. So at the moment I have this where the input is telling it this is what you need to say, and this is called in all the different places where I want it to say things. But if I was just to break this node, then I could write in here something. So let's write in hello world. And then because the speaker is being told to read some stuff from the main menu, if I hit play now, it's just going to say hello world.
Hello world.
And there you go. I'm going to plug this back in so that it continues to work. So how do we take this stuff and actually make it work with something in game? I'm going to show you an example with the HUD. So I have a very simple widget that is set up. It just has this one little HUD panel, and as part of that I've got a tutorial panel and a propped panel. In the tutorial panel, that's what I've been using for this example. I've just got a little background and I've got some text. I've actually been quite lazy with how I've set this up, so the render opacity is at 0 currently, so you won't be able to see it, although you can see where it lives by clicking on these. In the graph on Show Tutorial, this is where the tutorial text gets set. It sets the text on the actual widget itself, and then I have a little calculation here for how long it should show it for. So this is built in a kind of data-driven way where we have a HUD trigger example. So if I go onto Game Files, Text-to-Speech, I have a tutorial collision. This tutorial collision is just a little collision box which goes down, and when the player interacts with it, it will show the tutorial on the HUD, and it will display the tutorial text which I ask it to, and then it will destroy itself as an actor. So if I click on here, you can see that here I'm actually writing what that tutorial text is. So I've got use WASD to move. And just to kind of show you how that works, I'm going to play this and I'll move over to it now.
Use WASD to move.
But if I was to grab this and change this text to something like, let's do Hello World again. I can save it and play, and if I go over now,
Hello World.
You'll see that it's updated. So on the tutorial collision, we're using the action show tutorial. So on the HUD, we have show tutorial, and down here we have say async. So this is again where it's just saying those things. We have the tutorial text, which we're setting in the actual level itself. And then we have the target of the speaker and saying that it is a normal speech to use. And this is a really simple way of getting it to say things because we're directly using the kind of say async stuff here. We're not actually using that speak function that we have. So if you're looking for like a quick way to get in and get prototyping, then this would be a way that you could do that.
Now I'm going to give you an overview of how ReadSpeaker is set up in the game instance.
So in the project, I've got content folder open. I want to click on Game Files and then Game, and then I have Game Instance BP. If I open that and go onto the event graph, then I'll see that there are two areas that have got big comments around them. This big green area is called at the start of all levels to initialize the player settings. So what this does is it grabs the ReadSpeaker speaker and it sets the variables that we have in our options menu. So you can see that there's text-to-speech speed, pitch, volume, and voice. Speed, pitch, and volume are all ints, and if I go to these variables, you'll see that there's a default of 100 for each of them. For the voice, this is set up with an enum. Going into the text-to-speech folder and clicking on voice enum, you can see that I have display names for feminine 1, masculine 1, feminine 2, and masculine 2. And the description I have here is the feminine robo voice and then the name of the voice and the name of the pack as well. So these will be found on the ReadSpeaker Google Drive link that has lots of different voices that you can choose from. So I have Alice, Adam, Aaron, and Samuel. This comment here is adjust text-to-speech values. So I have some custom events here for setting the speed, the pitch, the volume, and the voice, and setting the audio description voice, and then changing between the voice types. I'll go through these one by one. So the first one is set text-to-speech speed. So this is taking our speed variable, it's timesing it by 4, setting the speed, and then it is grabbing the ReadSpeaker speaker, grabbing TTS speaker, and then setting the speed. And there's a little print string here for being able to see the speed if you want to plug that in and view it in strings. This is pretty much the same for both pitch and volume. It's just a little bit of different maths in terms of what it actually puts into the values. And this is because if I open up the speaker and I go on text-to-speech speaker here and go down to our characteristics, you can see here that there's the voice and then the volume, pitch, and speed. And these are all different sliders. This one's 200, 100, and 100. You can see that the two 100s here are different in the amount that they can get to. So pitch can go from 100 to 200 and down to 50. Speed can go up to 450 down to 50. Sorry, go up to 400 and go down to 50. And volume can go from 0 up to 500. So because these are all different values, there's a little bit of different maths that's required to set what that is going to be when it actually plays. You can also set differences between the pause and comma pause here, but I haven't made any changes to that. And back to our game instance. For setting the text-to-speech voice, the enum comes in and sets the voice, and then I have a enum select mode here, which takes the enum, and depending on what the input is, it changes it to the relevant code for the voice pack, and then sets it as a string in the speaker. The same thing for setting the audio description voice. We have TTS audio description voice and setting the string again there. When we switch between audio description and narration, we want to make sure that the audio description settings are preserved and the narration settings are preserved. So when we set to audio description, if it is audio description, we want to set to a new speed, which I've got as 120, and this is just a speed which I find is good for the audio description being read back. Obviously, you can have your players adjust this in the same way that we have it adjusting for the narrator, but this is just the speed that I've chosen, and also setting the pitch. So this is just going to change those things to make sure that it's not adjusting the speed or pitch that we have for the narrator. The volume is staying the same, and then we're setting the voice pack depending on whether or not it is the text-to-speech narrator or if it's audio description. And then to switch back, if it's not audio description, we're taking the speed variable that we have here and the pitch variable that we have in the game instance. We're setting those, and then we're just setting the correct voice pack again.
So one of the biggest things narration is used for is narrating menus.
And this allows players without sight or players who struggle to read or who are visually impaired to be able to interact with menus because they're being read out to them as opposed to having to rely on actually seeing them. This is my main menu and it's got 3 buttons in it. I've set up my main menu in quite a data-driven way, so it's going to be quite easy to add things and change things. So all of these buttons are also individual widgets, and they have a set of variables, and they're literally just a button and some text, and it has the button name here. This text variable is exposed on spawn, so that when I'm hovering on the button here, you can see that there's a button name and button ID, and I can set those things here. So I've got play options and quit. If I go onto the graph for the menu, I have this event graph here. The first thing it does is it binds some events, but I'm not going to go over that too much. But the important thing is when it has finished binding events, it is going to read the intro. It's going to get button speech. It's going to take the text to speak, is going to append it. So I've got some intro text here. So if I go back onto here, my intro text is this down here. And I'm just appending a string, which is the introduction text, goes in first, as you can see there. Then I've got set in the context, so it says this is the main menu. And if you had that as a title, you could just plug that in the same way I have with the intro text. And then it's getting the button speech of the current hovered button, which when we start up the game is play. So that gets that button speech, and that also adds it to this string. And then we're telling the speaker to read all of that out in one go. So what this results in is it reads out the introduction, it says main menu, and then it tells you the button that you currently have focused. One of the important things about navigating a menu is being able to tell the player the important information they need to know to move around and interact with that menu. It's not so useful if you just say play button, because Players will want to know, okay, but which button do I need to actually press to do that? And is this one option, or are there other options on this page? What else can I do? So this is kind of my data-driven way for setting up button speech. So this is a function called button speech. I'm using the button array, which I create, and the current selection to grab the right button. So I'm casting to my button. And then from there, I'm getting the button text, which is its name. And I'm adding that in the top. And then afterwards, I'm saying this is a button. Then I'm getting the current selection and adding 1 to it. So in an array, your current selection would be like 0, but 0 of 5 isn't going to make a lot of sense to a player. So we have, for example, if it was 0, 1 of 5, because we're adding 1. And then we're getting that length of that array and plugging it in here. So we're saying the name of the button, 1 of 3, and then we have a comma, and then we have A to select. And this one here, I've spelt it out phonetically because some of the voices don't always say A the right way, and I've kind of got it set up so that you would use a gamepad. But what you could do is you could have some controls maps that would be able to change depending on what the input is. So you could say like circle to select or A to select. And if you spell those all out in kind of like a data-driven way, then you can use the phonetic spellings that are most appropriate for the voices that you're using. So that's the only reason that I have this separate there, is the idea that you can plug it in so that it can change depending on if you're using mouse, keyboard, controller, whatever. And finally, it returns the text to speech. When you're navigating up and down, there's some code here for if the navigation is valid, using some ints and some branches, and then unhovering and hovering. And if I go onto my button and I go down onto hover, you'll see that when the button is hovered, it will call read button. In my main menu, I have a function to bind events. For each of the buttons in the array, when read button is called, it will do the speak button. Speak button will get button speech, as I've just demonstrated here. It will grab the menu speaker and it will tell it what speech it needs to say. And then this is just our speak variable from the speaker. Some other important things to remember are when you're doing different kinds of interactions, for example, a slider. The contrast is pretty bad here, but it says slider name, there is a slider underneath it, and then there is a value as well. In event construct, I have setting the name and the value for the slider, and this just goes back to the game instance that we saw earlier. It grabs the option that it needs, and I have this function here, which is get speed pitch volume, and it is setting the slider value and then taking that value and setting the text underneath it. When we get option speech for sliders, we're doing a similar kind of thing that we are with buttons. So I've got the slider name. It will read that out. It will then tell you that it's a slider. It will take the current value by getting the slider value, truncating it, and then turning it into a string and putting a percentage symbol on the end of it. And then there's the option interaction here as well, which is D-pad left or right to adjust. I've got another UI piece here as well, which is a list option. So this is what I'm using for changing between the different voice packs. And this is just a button, and within it, it has a left icon, it has the option name, and it has the right icon. And this is what I use to switch the voices. There's a couple of enums here, but the important thing to look at is, again, getting the option speech. So we want to get what the list name is, we want to get what type it is, its current value, and we can take the enum and change that into a string to put it in there, and then the actual interaction down below. Again, if I go on to, this time, the options menu, and look at the bind events function, you'll see that for each option that's in the array, if it is a slider, then it will bind speak value to read value and bind read slider to speak option. When we go into speak value, we'll be able to see that we get the option speech, and then it is just the value string that we're taking and putting here. And the reason that this speak value is important is because when you're updating the slider or the list, you want it to tell you what the new value is, but without all of the other information that you had before. So this will just tell you, if you're changing the speed from 50% to 20%, it will update as you move it, and it'll just go, if we're doing 5-degree intervals, it'll go 50%, 45%, 40%, etc. For speaking the option, I have another function here, which is get option speech. Gets the option that it needs, it gets that option speech, and it takes all of those strings that we have set in our list option and in our slider. So option name, option type, current value, and the interaction with it. And it puts it into a big old append, very similar to what we had in our main menu for our button. So this was the main menu one. We've got the name, it's a button, where it is in the place of the list, and then how to interact with it. If we go into options menu, we're plugging all that in. So we're plugging in the name to the top, putting in a pause. We've got the type, and then we've got a pause. We've got the current value and a pause. And then we have here where it is in that array again. It's done exactly the same way as before. And then the option interaction. And then at the very back, at the very end, I have B to go back. And this is just because in this options menu, pressing B will always take you back, will always exit you out of things. So you can add on extra stuff to say. If you're interested in how options should be read out to the player, then I recommend going and looking at the Xbox accessibility guidelines. They have a menu narration section which explains to you how things should be read out and in what order, and when things should be updated or read out again. One of the important things to think about with this is hierarchy. So you're telling the player what the option is that they're hovering over first. You're telling them what type of option it is, and then what its current value is. Then you're saying whereabouts it is in the list, how to interact with it, and then any tertiary actions, like going back out of the menu. It's important to think about that hierarchy because players will want to know the most important stuff first. So if they're going through the options menu, you've told them they're in a list. You can navigate to go like left and right to adjust the volume. So they start to navigate left and right. Now they can go down to another option and they know immediately, okay, this is now the pitch option and I can adjust it by doing this. And they don't need to listen to all of the other text that they might have heard already. They can just go, okay, cool, I can adjust this without having to worry about listening to B to go back. So when it comes to changing things like the speed or the volume or the pitch with the sliders, I have a little change value thing here. And this is just bound to when the slider is updated. So you'll find that in the slider option, I've got it set up so that when you navigate left and right, it will change the value depending on if it's a slider or a list option. So I'm using some custom events for this. So on change value, I've got a little bit of math to figure out if the change is actually valid. So it means if the slider's at the top or the bottom, it won't keep going. The important thing with this is that it doesn't do anything if the value isn't changed. So when you're adding in your sound effects, one of the things that can be quite difficult is if you have like a ticking noise for changing things in increments, but you get to the end of the slider and you continue to hold either left or right or wherever, and it keeps making that ticking noise. For someone who is visually impaired or who's relying on narration or audio, that kind of stuff is going to keep going, and then if there's no narration in particular, they won't know if the slider is ever reaching the end because it will just keep making that noise. So that's quite important that if it's not doing anything, it's just fully not doing anything. So we don't have any other audio set to this. If it's valid, it'll just set the slider value, which is fine. And then the important thing here is to save that value in the game instance. Saving the value in the game instance is the way that we can preserve the settings between levels. So we have 2 levels in the ReadSpeaker demo project. we have our main menu level and our demo level project. The game instance is something that is created at the beginning when you launch a game. So it means that it's going to preserve throughout whatever levels you're going through. So we set that value in the game instance, we set the slider text, and then we call the read value event. Remember as well, when you're looking at this and you're changing the values, if we go into the game instance, it will take change value. I have a little switch option on enum here, and it will take it to the relevant event in terms of adjusting the values and do the little bit of math that it needs to do depending on where it is. And remember that you have these print strings here that you can plug in if you need to. You can do all of this for a different set of things. So for example, if you wanted to have changes to the pitch or the speed for a audio description voice, you can copy these events, change the names to be like set TTS AD pitch, and then you would just create a new variable that was TTS AD pitch. The same way that we have TTS voice and TTS AD voice, you would just have TTS AD pitch and TTS AD speed or whatever. Depending on how complex your stuff gets, it could be worth looking into streamlining this a bit more by storing it in some kind of data table, so that you have like your narrator voice has its own set of settings and its AD voice has its own set of settings. And then if you have different NPCs, they would all have their own different settings as well. And then that could be a way to make this a little more tidy and have less in terms of different functions for setting different voices. Finally, there's the audio description example. So this is using the audio description voice that we're setting in all of our settings. And this is very, very similar to the HUD trigger example. It's just a collision box, and when the actor overlaps with it, we're telling it what audio description we want to describe. This time we are pushing it through to the speaker. So we're saying audio describe and the target is speaker. So if I open that, you'll see that it is going to get the game instance. It's going to set the voice type to audio description, and then it is going to speak the text. And at the end, it's going to look after itself, and it's just going to set the text, the voice, back to the narrator voice so that we're cleaning up. Again, this audio description is exposed on spawn and editable. So if I click on the box, you can see that this is where I'm actually setting what that audio description is. And this is particularly helpful for if you're designing levels or making levels. You can put in these collision boxes, and then whoever is making the level can spend a little bit of time just describing what the scene is. So you could put it and be like, you're looking out over a really gorgeous vista and you can see a sunset in the background. There's a big creature that's sort of leaning over towards you. And then a little bit further down the track, you can put in another one, and you can write, you're heading down this path into a kind of ravine area. It's very lush and grassy, and there are some birds nearby or something. So it's built to be very much a case of you just put it in and you set what you need there. So people don't have to go into the blueprints to change it. They just need to put the collision box down and change what the audio description should be. This kind of stuff can also be used for talking to NPCs or some assistants or companions or buddies. ReadSpeaker has a whole range of voices available, and you can use the same kind of system to voice your NPCs or add voice in other ways. Things like a helper or companion, looking at stuff like God of War, where you have Kratos' son who is helping you with hints in terms of how to do a particular puzzle, or whether or not there's someone to watch out for in different places around you. That kind of thing can also be applied to this. You can have different voices set up and different settings for audio description, and then have your character voices separate again. And again, you would just change the speaker the same way that I'm doing here. So instead of having audio describe, you might have an event for helper voice. And it would grab the game instance, it would set the voice to the helper voice, say the stuff that it needs to, and then set it back to just tidy itself up afterwards. So that's the ReadSpeaker demo. The ReadSpeaker demo is available on GitHub. There's a README which explains how to download it and how to run the project, and there's some extra information in terms of pushing to the repo and the project intentions and what you can do with it. There's a ReadSpeaker plugin that's also available for Unity, which can be used for exactly the same things. It's just that I've built this one in Unreal. And you can also get the ReadSpeaker demo API for other engines. One of the great things about the ReadSpeaker plugin is that it is free to use in terms of a trial, so you can use it for as long as you'd like. You will have been hearing the watermarked audio going on whilst the voice was speaking, that kind of music in the background. But what this means is that you are able to use this and play around with it as much as you like in Unreal or Unity to be able to test out TTS, see how you can use it best for your gaming projects, and also just worry about paying a license fee when you release your game. So there's no upfront costs. You can try it as long as you like. You can ask questions and ask for assistance, and hopefully this will help you to make your games more accessible. If you have any questions about the demo or anything that's gone over, please leave them in the comments below. If you want to find out more about ReadSpeaker, then you can visit ReadSpeaker Applications for Gaming at www.readspeaker.com/applications/gaming.